This is SLI1. Odd problems worked out for CP Algebra 1. All right, problem number 1. Not going to draw the whole number line, but we notice we have an open dot at -5, and the line continues this way. So we want to write the inequality in interval notation. So we should know that this is x is greater than -5, and the reason it's not equal to is it's an open dot. So the interval notation would say I want values that are going to the right from -5. So I'm going to have a rounded bracket from -5 going to infinity. That just grows bigger and bigger. Problem number 3, we have an open dot at 0, and it's going to the left. So again, this is, we want values that are less than 0. So we're going to go, going this way is -infinity. That's where we start, because we always read it left to right like we'd read a book, to 0, rounded bracket. Problem number 5, we have x is less than or equal to -7, so write the inequality in words. Everything. So x is less than or equal to -7. Number 7 says graph the inequality and then write an interval notation. So we have a number line. We have 0 here. Let's say we have 2 here. We have an open dot going this way. That's where it's shading, so that's going to -infinity. Interval notation would be from -infinity to 2, rounded bracket. Number 9, we have m is greater than or equal to -2. So on our number line, we have 0 here, we have -2 down here. This one has a solid dot because it has the equal sign and it wants values bigger than that, so it goes that way to infinity. So interval notation is going to be a square bracket from -2 to infinity. The infinity always has a soft bracket or a parenthesis. Number 11 says the temperature of a refrigerator chuck must be kept at or below 38 degrees. Okay, so it can be up to 38 degrees, and it's less than or equal to because it says up to. And we want to say, is this continuous or discrete data? Well, can we have decimals of temperatures? The answer is yes. So this is continuous. It's continuous data. And then the interval notation, I mean, how cold are we really going to get? I mean, theoretically, mathematically, we're going from -infinity to 38 square bracket. We probably would never get down to -infinity for a temperature, but mathematically, we're fine. 13, a football team scores between 10 and 28 points. So 10 is less than or equal to x, which is less than or is equal to 28. So the reason we don't have solid brackets is because we're scoring between those two. So if we were to do an interval notation, we'd go 10, comma 28. And then this would be discrete data because I don't have decimal points that I get. (15), we want to solve this. So I have x minus 7 is equal to -5. So just add 7 to both sides. 17. Solve the following. So 7. Oops, I made a mistake. Let's erase that. 7 over 3x plus 3 over 2 equals 23 over 6. Okay, so we want to clear the denominator. So 3, 2, and 6 all go into 6. Okay, some of you might have said 18 or 12, and you'd still get the right answer. It's just you'd be dealing with bigger numbers, but it would still reduce down. 3 goes in 6 twice. 2 times 7 is 14, so I get 14x. 2 goes in there 3 times, plus 9, because 3 times 3. 6 cancels out, so I get 23. And then from there, we're going to subtract 9 from both sides. Those cancel. And so that's going to give me 14. Divide each side by 14. Those cancel, so I get x equals 14 over 14, which is just 1. And last problem, if we can get to it. Number 19. I have y plus 3 equals 2y minus 5 plus 10. So it looks like I can go ahead and drop those parentheses. So then I have y plus y is 2y plus 3. There's nothing to multiply over. I mean, 1 technically. Equals 2y minus 5 plus 10. Combine like terms on the right. And if I subtract 2y from both sides, those cancels, and I wind up getting one of the great mysteries of math. 3 is equal to 5. No, that's not true, so there is no real solution. And again, you want the R for the real number system.